analytically, partition A to B with the zeros of f. Then integrate f over each subinterval, and then add the absolute values of each of those intervals. Now in section 5.2 or 5.3, they told you to take the area of the one minus the area of the other. It was area above the x-axis minus the area below the x-axis. And then that would give you the area. But what we're going to, this will be another way, so then you don't have to worry about which one's positive, which one's negative. Just do all of the math and the absolute value portion, or not the absolute, when you get numbers, you do the absolute value of each. So on this one here, finding area using antiderivatives, find the area of the region between the curve and the x-axis of y equals 4 minus x squared on the interval of 0 to 3. Well, the first thing we have to identify is when does this guy cross the x-axis? So we do 4 minus x squared equals 0. So x squared is equal to 4. I move the x squared over. X squared equals 4. Square root both sides, and you get x equals plus or minus 2. Now, only one of those two numbers are in this interval, and that's 2. So we're going to write the integral starting at 0 and ending at 2, because at this point it crosses the x-axis. 4 minus x squared plus, because we're going to add the absolute values here, plus 2 to 3. Because one of these two is above the x-axis and the other one is below the x-axis. How do we know? Because we did the math over here. We found out when x equals 0. When x is plus or minus 2. So we can also consider this as a parabola, an upside down parabola. So it's going to be above the x-axis from 0 to 2 and then below from 2 to 3. But we don't have to really know that. Antiderivatives. So this is going to give me 4x minus x cubed over 3, evaluated from 0 to 2, plus same antiderivative, 4x minus x cubed over 3, from 2 to 0. I'm sorry, 2 to 3. Now, before you start going, well, hey, I'm going to just, why can't I just go ahead and add or subtract these up? Because you're doing absolute values. Otherwise, we would just evaluate 0 to 3. Okay, so we plug this one in, but I know I'm going to be doing absolute values, so let's go ahead and get the absolute value symbols on here. So this is going to be 4 times 2 minus 2 cubed over 3 minus 0. If I plug in 0 to those x's, I'm going to get 0. Plus the absolute value, now I'm plugging in 3. I get 4 times 3 minus 3 cubed over 3 minus, parentheses, 4 times 2 minus 2 cubed over 3. Absolute value. Now I have to take the absolute value of this, the absolute value of this, and then I can add them up. That's what I was meaning. That you can't just go and subtract those out. So I'm going to get 8 absolute value of 8 minus 8 over 3 plus, this is going to give me 12 minus, 3 cubed is 27, and 27 divided by 3 is 9, so 12 minus 9 minus your 8 minus 8 over 3. Yes, those two values are exactly the same, but keep in mind we're going to be adding the absolute values of these. Okay, I have to get a common denominator over here. So that's going to give me 24 over 3, because 3 goes in 24 8 times. And 24 minus 8 is going to give me 16 over 3. Absolute value of that. Plus the absolute value, 12 minus 9 is 3, minus, and then this, just like this over here, is going to give me 16 over 3. So this one's already positive, 16 over 3, plus, but this guy's going to give me something negative, because if I want a common denominator here, it is going to be 9 over 3 minus 16 over 3, which is going to give me negative 7 over 3. So this becomes 16 plus 7 all over 3, or 23 over 3. And we're done. So that is the area. So it's one of those, colored I guess would have helped a little bit here, but keep in mind you're separating the integrals, and you can always do the one and then plus and then do the other. And because they're asking for area, we're taking the absolute value of each. In 5.2, I think it was, we could have also just subtracted the 2, and then you would have gotten a value here, and you would have subtracted, and the 2 negatives would have cleared it up. Anyways, this negative and this negative would have made it positive. That would be without absolute value symbols. Okay, so if we go back and read our things, partition A to B with the zeros, integrate, and then add your absolute values of the integrals. Okay, let's try another one. I want 2 minus x between the intervals of 0 to 3. Well, if 2 minus x equals 0, then x would have to be 2. So different integration or antiderivative, but our limits are the same. So 0 to 2, 2 minus x dx plus 2 to 3, 2 minus x dx, minus sign. So antiderivative, so we can say instead of, and you have to do this setup. On the AP test, they will look for the integral, and that alone can be 1 point. So we get antiderivative is going to be 2x minus x squared over 2, evaluated from 0 to 2, plus 2x minus x squared over 2, evaluated from 2 to 3. Okay, so plug in 2. This is where I bring in the absolute value symbol. So 2 times 2 minus 2 squared over 2 minus 0. Because now I plug the 2 in. Make sure you plug the 2 into everything. And I plug in 0, I'm going to get 0. And the absolute value plus, and then this one here. Absolute value of 2 times 3 minus 3 squared over 2 minus, and then what you did over here. 2 times 2 minus 2 squared over 2. Absolute value. And like I said, if it's too much doing the whole thing at once, do each absolute value portion on its own. That's what I'll do on this one, so you can see that it's not going to change anything. Okay, 2 times 2 is 4. And 2 squared is 4, and 4 divided by 2 is 2. So I get the absolute value of 2 here. Okay, plus, and then we do the math over here. 2 times 3 is 6, minus 9 over 2, 3 squared, 9, minus, and we now know what this value is because we did it over here. Now you have two choices. You can double check and make sure you get 2 there, or you can go with, you know what, I know what I'm doing, and I'm going to get 2. And keep on doing the work. So 6 minus 2, and I know you guys go, hey, I'm just saying, but I'm still subtracting. 6 minus 2 is 4. So I'm going to get 4 minus, and this is 4.5. So this is what I'm going to get. 6 minus 2 is 4. 4 minus 9 over 2, 4.5. So I'm going to get a negative 0.5. So in the end, I have 2 plus 0.5 or 2.5. If you left it as fractions, you would have gotten 5 over 2. Pick your poison. I tell you to leave it as a fraction, but that's especially if, like the last one we had, like 8 over 3. You don't want to change that to a decimal value, but 5 halves, it's 2.5. It doesn't matter. It's an exact value either way. Okay, let's try one more. So this time we have 3x squared minus 3 from negative 2 to 2. So we come over here, do our little math. 3x squared minus 3 equals 0. So if I divide through by 3, I get x squared minus 1 equals 0. Move the 1 to add 1, move it to the other side. X squared equals 1. Square root both sides. We get x equals plus or minus 1. And they are both in the interval, so we've got a lot going on with this guy. So we're going to break this up from negative 2 to negative 1, and then negative 1 to positive 1, and then 1 to 2. 3 integrals we're going to have here. So the first one is negative 2 to negative 1 of 3x squared minus 3 dx plus the next interval, which is negative 1 to 1 of 3x squared minus 3 dx plus the interval of 1 to 2 of 3x squared minus 3 dx. Now what's nice is we know that we're going to have the same antiderivative throughout. Antiderivative of this guy is going to be 3x cubed over 3 minus 3x. But we're just going to go ahead and clean it up first. 3's cancel. So x cubed minus 3x evaluated from negative 2 to negative 1. Okay, plus, sorry about that. And then again, the antiderivatives are the same. So x cubed minus 3x evaluated from negative 1 to 1 plus x cubed minus 3x evaluated from 1 to 2. Okay, so on these ones here, we plug in negative 1. So you get negative 1 cubed minus 3 times negative 1 minus, then you plug in 2. Negative 2 cubed minus 3 times negative 2. And this is going to be the absolute value of it. Plus, and then do it again here. 1 minus 3, and I'm just going to straight out do that because it's 1. It's not going to change. Minus, parentheses, negative 1 cubed minus 3 times negative 1. Absolute value symbol, plus, and then the last one. 2 cubed minus 3 times 2 minus, and then plug in 1, you get 1 minus 3. Absolute value. I was afraid I was going to get that last absolute value in there. And so I'm going to do each one of these separately, clean them up. So this one here, negative 1 cubed is still negative 1. Negative 3 and negative 1 gives me positive 3. I almost added. Minus, and leave that in parentheses. This guy is negative 8 plus 6, so we're going to get a negative 2. So, yes, I'm going to leave those absolute value symbols on them. So I got negative 1 plus 3 plus 2. 2 negatives make a positive. Oh, do you see my mistake? I just saw it. Sign error, that's something to be really, really cautious with. It's right here. I I think, -1, -3, minus, oh, yep, that's okay, minus, and all of this crap in here became -2. So these two are going to become positive, blah, blah, blah. So -1 plus 3 plus 2. So you get 5 minus 1, so you're going to get 4 here. Okay, plus, I almost made a mistake there. Better for me to catch it than to not catch it, even if it wasn't a mistake. Absolute value. So this guy here, -1 and -3 is, or I'm sorry, 1 and -3 is going to give me -2 minus what's in parentheses. So this one here, and we can't come back over here because that was the whole mix where the other one had 0. That's why we were able to do that. So you have -1 plus 3, which is -2. No, +2. And negative and a negative, that's going to give you the absolute value of -4. These are so far apart, I'm afraid that you're going to miss what I did throughout all of these. So I'll just put a plus sign down here. And then the very, very last one. 2 cubed is 8, minus 3 times 2 is 6, minus, and the 1 minus 3 is going to give you -2. So we get 8 minus 6 is 2, minus the -2, that's going to cancel out like this, and we get 4. We have the absolute value of 4. So in the end, you had the absolute value of 4 plus the absolute value of -4 plus the absolute value of 4. So really we have 4 times 3, which is 12. Which just tells us that it's below the x-axis between -1 and 1. All right, don't overthink, I know, don't overthink this, you say this so much. But keep in mind, it's the same process all the way through. And if you're going to make a mistake, you'll either make the mistake and do the antiderivative or in all of the math. You're going to make the mistake in one of those two places. But if you're doing homework or on a test or whatever, you can always double check your work. Because you can also throw it into a calculator. So how to find that total area numerically on the calculator? To find the area between the graph of y equals f of x and the x-intercept over the closed interval a to b. Now, you guys know that this is for like a TI-83. TI-83. But we have TI-84s and Inspires. And so you're going to put the whole thing in a to b, absolute value of f of x, and dx. Because what it'll do, the calculator itself will figure out where it crosses the x-axis, and it will do the absolute values. If you don't do the absolute values, it's just going to give you it's going to evaluate the function from one place to the other. Okay. So that's what we're here, double check the previous problems using the calculator. So now I've already done these. Now, if you, worst case scenarios, you need the reminder. You do an alpha window 4, it'll take you there. And a lot of people just have like math 8 or something. So if you put these into the calculator on this one will give you a 7.66602. Guess what? This one here basically represents 2/3, so it's going to be 7 2/3. And if you remember, we got 23/3 for this one. Guess what? 3 times 7, 21, plus 2 more is 23. This is 23/3. But putting that into the calculator with the absolute value, that's the answer you got. This one here came out to be exactly 5/2. Now remember, let me write these, how you put these in the calculator. So this one would be 0 to 3, absolute value of 4 minus x squared, dx. This one here would be also 0 to 3, absolute value of 2 minus x, dx. And then the last one would be negative 2 to 2 absolute value of 3x squared minus 3 dx. And that one, it gave us 12.000, and then like a 1 or something afterwards. So basically 12. I'll pause this for a second. Now I'm going to put this next little bit in red, because if you forget your absolute value symbol, I want to just put it in red. If you forgot the absolute value symbol, so if you put in 0 to 3 of just 4 minus x squared dx, you would have gotten an answer of 3. Quite a ways off from that 23 over 3. This one, if you forgot the absolute value symbol, if you would have done 0 to 3 of just 2 minus x dx, you would have gotten an answer of 1.5. And then the last one, if you had forgotten to put in the absolute value, negative 2 to 2 of 3x squared minus 3 would have given you an answer of just 4. This one, if you remember, because we just did this one, you had the 4 plus the absolute value of negative 4 plus 4. The 2 of the 4s would cancel each other out, and then you would have been left with the other 4. So this is the integral value, but it's not the area under the curve. So there are two differences. You've got to watch for if they're asking you to find the area under the curve, or if they are asking you to find, or just to evaluate. All right, well, we are done on this one. So at least one of the videos is fairly short. So I just bid you farewell and good luck.